For example one, we want to find the radius of conversion of the series. So first of all, we're going to have to test for the conversion. So you can see that right here we have a constant raised to the power. So I'm going to use the ratio test. So for the ratio test, I need a sub n. So if a sub n equals to x plus 6 to the n power over 6 to the n power ln n, then I'm going to take the limit. We want to take the limit n goes to infinity a sub n plus 1 over a sub n. So we're going to plug it in. So what I have is going to be x plus 6 n plus 1 over 6 to the n plus 1 ln n plus 1. So I add 1 to n. I'm going to multiply by the reciprocal because we divide by a sub n. So it's going to be 6 to the n power ln of n over x plus 6 raised to the power of n. We need to simplify. So we can drop the absolute values for ln. So we ended up with ln n over ln n plus 1. Notice that I cannot simplify those two. Now, the power I can simplify. X plus 6 over 6. So we get to cancel this one, we left with just 6. And then we get to cancel this one with this one, we left with x plus 6. Now, we're going to take the limit of that. So we have the limit. Let's take care of the ln. So ln sub n over ln of n plus 1 is going to give us the limit n goes to infinity ln of x over, I'm sorry, I changed to x, over ln of x plus 1. Now you can see that we have the case of indeterminate. That's why I changed to x. And I'm going to take the derivative because we are using L'Hopital. So if I take the derivative of ln x, it's going to be 1 over x. And then the derivative of the bottom is going to be 1 over x plus 1. So when you simplify that, we ended up with x plus 1 over x. I simplify one more time. You can see that x divided by x is 1. 1 divided by x, we leave it. And that's going to go to 0. So the limit is going to be 1. So by the ratio test, we know the series converges when x plus 6, the absolute values over 6 less than 1. So I need to solve for this. So I'm gonna multiply 6 over. So what we have is x plus 6 less than 6. So you can see that r is 6. The radius of conversion is 6. Now we're going to drop the absolute values. So I have negative 6 less than x plus 6 less than positive 6. So it's going to be negative 12 less than x less than 0. Okay? So now we're going to test for the interval. So we got the endpoints. I need to test the endpoints, which is x equals to negative 12. So what happened when x equals to negative 12? When x equals to negative 12, we're going to go to our series. The series converges by the alternating series test. When x equals to 0, we have this series. 1 over ln. This one right here diverges by the limit comparison test. And I compare this series with d sub n equals to 1 over n, which is the harmonic series. And we know that the harmonic series is divergent. Therefore, the interval of convergence is going to be including -12, but exclude 0.